Hi there. My name is Anand Venkateshan. I'm the founder and mentor of this platform called mentorscapital.com. I'm extremely proud today to say that we have absolutely the best test series for your CLAT preparation, right? And this confidence comes from the deep research that we've done, our years of experience in helping students clear these exams, and our extremely wide panel of experts who've actually been there and done that, right? As in cracked the exam in their own, years. Well, do check it out. Do click on the link in the description to access these tests. In today's session, though, I'm going to talk about the sample paper that has been released with, in relevant for CLAT 2023, the first paper of that has been released. And so without much ado, I'm going to get started on that. Well, one of the first things that you do when you're discussing data interpretation is obviously to talk about problem selection, right? And how do you figure out which set to choose, which set to attempt? And how to do that in this particular test? Well, there are 3 sets in this paper, right? Let's look at what these topics were involved in these sets. The first set was a question based on simple interest, and then there's a lot of data given in the table, right? So the second set then is based on digits and how they solve, how they work out in arithmetic equations, and the third set is based on time and work, right? Now, ideally, you should be in a position to judge the topic itself, right? Is it easy? Is it medium? Is it hard? How well do I know it, right? Which basically will require a lot of preparation, which is also a reason why you should consider preparing, using our test series, because not only you get those full length marks, but you also get practice questions from each of these topics that can come in the exam. All right, but staying on course, our assessment of the topic tells us that, first set and the third set come from easy topics, right? Time and work and simple and compound interest is not really a hard topic, but between the two, I'd say that the question difficulty is higher in the first set. The option choices look weird, they look intimidating actually, and there's a lot of data, right, that you need to sort of absorb and use. So from that perspective, set 1 would be slightly harder than set 3, but these are the ones worth attempting. Set 2, on the other hand, is one that I would categorize as medium to hard, because well, let's face it, there are multiple equations with 9 unknown variables. So it almost is like an LR set where you need to evaluate every given constraint, every given equation, and consider possibilities and then solve, right? So it's going to take a little bit of time, and mistakes can also happen. So attempt set 3 followed by set 1, and then come to set 2 if at all time permits. Okay, let's look at the first set now. The first data set is based on work. This is the third set in the exam actually, right? And what you're given is that there are 150 workers who are hired to build a water tank in 20 days. But suddenly 5 days into the task, there's a change of heart, and the target date is moved ahead, right? So it's moved to 15 days instead of 20, right? So 5 days, you have to build 5 days in advance, and obviously the question says how many additional laborers are required in order to finish the construction in this time, right? In the targeted time, right? Now, usually in problems on work, you can start with assuming either work or rate. This is a typical approach that I recommend all my students to follow, because then, you can solve the question almost in your head, right? And so here's what I do here. Well, I know that there are 150 laborers, workers, who can complete this task in 20 days, right? And we should also keep in mind that there's only one formula that you use here: work is equal to rate into time, right? So time is already given, but neither work nor rate is given. And so an easy assumption to do is to assume rate, right? When you have many people of the same type, equally efficient, let's assume their efficiency, their rate, right? So let's say one worker completes 1 unit every day. That's his rate. So obviously in this particular scenario, we have 150 workers who will have a rate of 150 units per day. And we know they work for 20 days to finish the task, right? Which means that the work itself should be a product of the rate in time, right? So 150 times 20 becomes 3,000. Okay, this is the amount of work that needs to be done. Well, what actually happens is that 5 days into the work, you need to finish it early, right? So you hire additional labor, right? But for the first 5 days, we know that there were 150 workers. And so the rate must have been 150. And this rate continued to stay constant for 5 days, right? So in those 5 days, first 5 days actually, how much work was done? Well, it should be 150 times 5. That's 750 units, right? So this much work is complete. Obviously, subtracting from the total, you'll get the amount of work left. That's 2,250 units. Now, who does 2,250 units? Well, the 150 workers still continue, but you hire additional labor. So you don't know actually how many people work. But what you do know is that they need to finish it in 10 more days, right? So the remaining work needs to be completed in 10 days. So 2250 units, for it to be completed in 10 days, you can calculate the required rate in this particular situation, right? You could basically say, I can determine what the rate is going to be. And obviously, rate can be determined by using the same formula. Work is equal to rate into time. We know how much work is left and we know when we want to finish it. So clearly the rate required should be work upon time, right? So that becomes 2250 divided by 10 or 225 units every day. All right. Now, I also know that one worker does 1 unit every day, right? So if you want to do 225 units every day, you need 225 workers to be working for you, which also tells you that you need to hire an additional 75 workers. So the answer to this question is option C. Now, question number 2 asks us, how long would the food, remaining food after the first 5 days, how long would it last when eaten by all the workers, right? Now, food, right? So far, we've dealt with, the actual work of constructing water tank, right? What about food? What are we told about food? We're told that there was enough food to last 150 workers and for them to be able to feed for 30 days, right? So we can do something similar. We can assume, let's say one worker eats 1 plate or 1 unit every day, which inherently means that you have, 150 workers, so they'll eat 150 plates every day. And in 30 days, they can finish 150 times 30, right? So they'll be able to finish 4,500 plates of food, units of food. So this is the amount of food that's stocked up in the canteen, let's say. Okay, this is the amount of food you have. Now, what happens to this food? First, it's eaten by 150 workers for 5 days, and then 225 workers come in and they finish the remaining food, right? So I can again do it in a step-up manner, step-by-step manner. I can say first 5 days, how much food gets consumed? That's going to be 150 times. Remember, I'm still using the same rate because we still have 150 workers, right? So rate remains 150 for the first 5 days. That consumes a total of 750 units, which basically means that I'm going to be left with 3,750 units or plates of food. And we know this food is now eaten by 225 workers, which means that the rate is not going to be 150, it's going to be 225, right? So 3750 equals 225 times, let's say, n days. And the value of n can be calculated from here as 16 and 2/3, right? And some of you, will directly mark it, but others will want to check, we only have 116 in the answer, so that should be the right answer, but let me still check, right? So how do you check whether this is correct? Well, only thing that remains is how do you convert 2/3 of a day into hours, right? So since a day has 24 hours, I can directly do 2 by 3 times 24. And you can see that 3 times 8 is 24. So that, simplifies into 16 hours, right? So 16 days and 16 hours into the last day is when the food will finish. That's option B. Question number 3 from this set asks us about, the pipes now, right? So first 2 dealt with the construction and then the food. The next problem deals with pipes that are used to fill the tank. You know that there are 3 pipes in the tank, but this problem involves only 2, right? So we'll probably solve the problem, using just the first 2 pipes, right? And instead of assuming work, you can actually use, the volume of the tank as a judge of the work, as a measure of the work, right? So here you can say the volume of the tank that is being built is 24 times 16 times 10, right? You could even assume a convenient value, but if you just take this value, 3,840 cubic meters of liquid can be filled in this tank, right? And since we know work is equal to rate into time, and we're told that pipes A and B and C fill it in 12, 8, and 6 hours, right? Or C rather empties it in 6 hours. So since you know the work and you're given the time, you can calculate the rates, right? So rate of the first pipe A, rate is work upon time. How much work? 3840 cubic meters. How much time? 12 hours. So 3840 upon 12, that works out to 320 cubic meters per hour, right? Doing this for pipe B, you get 480 as its rate. And then the question says that to start filling the tank with water, pipe A was open for 3 hours and then B was open, right? And when was the tank filled completely? So what you know is that, well, first I start A, then I wait for 3 hours, and then I start B, and then it gets filled at some point, right? So what if the tank took n hours to fill, right? Then what immediately you can deduce that A must have worked for the entire duration of n hours, but B must have worked 3 hours less than A, right? So n minus 3 hours is what B worked for. You know their individual rates and the time taken by them, right? So you can calculate the individual work done by them. So work done by tank A, pipe A will be 320 times n, work done by pipe B would be 480 times n minus 3. And a sum of these two should be equal to the total work that we set out to complete, 3,840, right? So the equation is a simple linear equation which you can solve. And the answer you'll get is that n is equal to 5280 upon 800, which roughly is about 6 and 3/5 of an hour, 6.6 hours, right? And there is only one answer with 6 hours, so that should be an easy draw, easy pick. But quickly you can check that 3/5 of an hour, and we know an hour is 60, so 3/5 of an hour is indeed 36 minutes, right? So option C is absolutely correct. Previous question, we also, we've already determined that the volume of the tank is 3,840 cubic meters. We also know that the formula we're going to use is work is equal to rate into time, and that the two pipes A and B have rates of 320 and 480 cubic meters per hour, right? So we already know this much. And now we know that that contamination was observed 4 hours, into it filling, right? So what happens in 4 hours? We know that if work continues for 4 hours, then A would have worked for the entire 4 hours. It would have filled for those 4 hours, but B was started 3 hours after A was, right? So B would have worked only for 1 hour. So how much work do these pipes now do, right? Well, they do 320 times 4 and 480 times 1 respectively. Add these to get the total amount of work done, 1,760 cubic meters. This is the amount of liquid, contaminated water that we filled in the tank. Well, next step is to find the amount of water in it, right? We know water is to oil is in the ratio 7:5, right? Which means 7 by the total, 7 plus 5. 7/12 will be water and 5/12 will be oil. Since we want to calculate amount of water, you'll simply say 7/12 of 1760 and calculate this to be 1026.67 cubic meters. That's option A, which is what you should mark for this particular question. And finally, you come to set 3. It talks about even though the contamination was observed, A and B were continued to run and C was now started, right? So at the 4th hour, this is what happened. And then 1 hour later, A and B are closed and C is kept running till it empties out the tank, right? How long does it take? That's the question. All right. So what you know is that, the work that we need to do is the volume of the tank 3840. We know rates of A and B. We can also calculate rate of C, but we'll have to assume that it does negative work, right? So C does minus 3840 units of work in 6 hours, which means it does minus 640 units or cubic meters of work in an hour, right? So we know that, individual rates, and we know that the analysis has to be how long, each of those pipe worked, right? So if you understand that, this question is very easy, right? So here's the way that you solve it. You think, okay, the pipes A and B are filling the tank and the drain is emptying it out. So let's calculate total amount of water that work that was done, positive work that was done. A and B worked for 5 hours, right? Which means A would have worked for the entire 5-hour duration, but B only worked for 3 hours less, which means only for 2 hours. What amount of work did they do in this time? Well, A did 320 into 5, B did 480 into 2. That totals to 2560 cubic meters of water. Well, this amount of water is filled up. Now, pipe A and B inlet pipes are closed and then outlet is allowed to work, right? So this will get emptied out. At what rate? At the rate at which C is empty is water, right? 640 cubic meters per hour. So you can simply now say that this water, which is 2560 units, will be drained at 640 units per hour, which means it will take N is equal to 4 hours, right? And so once you know that it will take 4 hours for the tank to empty out, this is 4 hours from, that the drain pipe works for, right? But the drain pipe also works for an hour when inlet pipes are open, right? So you can't count that 1 hour. So the answer, how long does the drain pipe take after the inlets are closed? How long does it take to empty the tank? Well, after it closed, it took another 3 hours, right? But from its very own start, it took 4 hours, right? So that's the slight difference here, which I hope you are able to account for. All right, and another piece of sort of reminder here is that all these sets involve, a lot of basics, right? At a back end, you need to work on, basics with that subject, and most of, our solutions, most of our problems in the DI sets, in the mocks, as well as, sectional and topic wise practice, heavily focuses on you building these concepts and you getting a lot of exposure to questions, and hopefully make you better at it, right? So do click on the link below to access free material for CLAT preparation, as well as, solutions to past year exams. All right, we come to the most difficult set here, which is the, actually the medium difficulty set rather, which is the first set, based on simple interest and based on this table. So it's actually smart of us to quickly do a recap. We know that the fundas we need are to understand simple and compound interest. Simple interest is charged on the principal, and the principal is the money that you borrow, so it doesn't change, right? So simple interest does not change. Every year it's going to be a constant. For n years, it should be n times 1 year's interest. Compound interest, well, we'll come to compound, but simple interest, there's a very simple formula, PRT by 100. And if you add the interest to the principal, you'll get the amount of money that is due to you, that you owe or money that is due to you, right? This is simple interest. Compound interest, on the other hand, it doesn't calculate interest as a percentage of the principal. It's actually as a percentage of what is due, which means it includes both the principal and the interest that, is owed to the money lender. And hence simple and compound interest, unlike simple, is not constant. It actually increases by R%, by the rate every year. It increases by that percentage. Right? And in terms of formula, you have P into 1 plus R by 100 to the power T. And by subtract, this is the amount. And if you subtract the principal from it, you get, the interest earned. And one last thing that you need to keep in mind is also something called non-annual compounding. What happens if, the bank compounds, or the institution or the person compounds interest half yearly or quarterly? Well, half yearly means that he's going to pay you interest 2 times a year. Quarterly means that he's going to calculate interest 4 times a year. And so the first variable that you need to work with is something called N, right? How many times a year does this happen, right? And if you know the value of N, then in the formula, you calculate an equivalent rate, R by N, right? If it's 10% per annum, then it will be 5% for half a year, right? So 10 by 2. So N R upon N is what the rate becomes, and T into N is what time becomes, right? So the formula changes slightly, but it remains and it retains its own logic, that compounding increases the amount by R% every period that it's calculated. All right, let's come back to the question. First question here says that you have the table and you're given that the rate of Sangrah is double the rate offered by Bachat Yojana, so 5% and 10%. We are also told that Sangrah Yojana sees double amount of investment, so we assume the principal to be P and 2P, right? And the problem itself says that the difference in the amount realized from Sangrah and the Bachat Yojana scheme was 49,600. So basically, amount from 2 minus amount from 1 as a difference of 49,500. Right? And we also know amount is principal plus the simple interest, so P plus PRT by 100. So I can simply construct an equation like this, right? 2P plus 2P into 4 into 10 into 4 by 100 minus P plus P into 5 into 3 upon 100, right? And this is equal to 49,500. Simply solve the equation to get the principal sum as 30,000 rupees. Right? So you invest 30,000 in Bachat Yojana, Sankalp does, and invest 60,000 rupees in the Sangrah Yojana. So we update those values in our table, right? So you can see 30,000 and 60,000 have been replaced as the principal for the first two schemes. Now this question number 2, tells us that Sankalp earns the same amount of simple interest from Jama Punji as he does from Sangrah. So basically schemes 2 and 3 gives the same interest. Right? So SI from 2 is equal to SI from 3. But SI from 2 you can find out, right? 60,000 into 10 into 4 upon 100. That's 24,000. Right? So Jama Punji also earns 24,000 rupees as simple interest. But here's the thing, you already are given the amount that you get back, right? That he gets back out of Jama Punji is 1,24,000. And from this 1,24,000, you already know that, you get an interest of 24,000. So basically principal plus 24,000 equals 1,24,000. And so the principal must be 1 lakh. And if the principal is 1 lakh, and then you can simply substitute the value of interest, right? We know 24,000 is the interest earned on this principal of 1 lakh. So 1 lakh into R into 6 by 100 becomes equal to 24,000, and hence rate becomes 4%, right? So what is the compound interest if it were calculated on this sum semi-annually, right? Now you can use the formula, but I'll also show you a quicker method to do it, which is to understand compounding, right? We know that Jama Punji gives me 4% per annum if it were simple interest. What happens if it were compounded semi-annually at the same rate? Well, that would mean instead of 4% being calculated once, you'll calculate 2 times, you'll calculate 2% each. Right? So compound interest for the first 6 months will be 2% on the lakh, that's 2,000 rupees. Compound interest in the next 6 months will be 2% of not the lakh, but lakh plus 2,000, right? And so 2% of that becomes 2,040. And hence the total compound interest earned would be 4,040 rupees, or option C. And I think you should also notice that since it's interest for 1 year and Jama Punji is 4%, we already know Jama Punji earns 24,000 rupees in 6 years. That's 4,000 per year, right? So if my simple interest on it is 4,000, my compound interest should be a little more than 4,000. Easy to sort of mark option C, right? With very less calculations. All right, question number 3. Now, to solve this question, we've already calculated, for the first 3 schemes, what were the principles, what were the rates, what were the time periods, right? So when the question says find the profit percentage, all you need to do is add up the principles, add up the amounts, subtract them to get the difference, that is the earnings that you get from interest, that's 52,500. And once you divide this by the sum invested and multiply with 100, you get the overall profit from this investment, which is 27.6%. That's option D from the given choices. Question number 4 is slightly different, right? Gives you more data and then it gives you additional information, right? So let's start with, what we know, right? We know that the ratio of the rates, for these 2 new schemes is 3:4. So let's assume 3R and 4R to be the rates. But it also turns out that the rate of interest of Sanchay is said to be double that of Jama Punji. We already know Jama Punji earns 4%, right? So double of 4% is 8%, right? So Sanchay's, rate that we've assumed is 4R, right? So immediately equate 4R with 8%. That means R is 2, which means then the Dhan plan earns 3R or 6%, right? So we've calculated rate of interest for both the schemes, right? Since we don't know the time, we'll assume the time to be T years for Sanchay, and Dhan plan, which is 1 year less than Sanchay, should be T minus 1 years, right? So you know the principal, the rate of interest, the time taken, and we're also given information about the principal. Sanchay invests, in Sanchay it's 50,000 of investment. In Dhan plan, it's 160% of that, works out to 80,000 rupees, right? So 50,000 and 80,000, right? So simply calculate the difference, right? Now here is where the crucial part of the problem hinges, right? The problem merely states that the difference of their interest earned is 800 rupees. It doesn't say which one is greater, right? So immediately you should imagine 2 possibilities. Either the 4th scheme exceeds the 5th scheme or the other way around. So consider both possibilities, or you could consider one possibility, but make the difference as positive or negative of 800, right? Which is something you can do, right? PRT by 100 minus PRT by 100, but also equal to plus minus 800. If it's plus 800, then fourth, simple interest in scheme 4 is larger. If it's negative, then simple interest in scheme 4 is smaller, right? Which means 5 is larger. And then if you solve these two equations that you get two solutions, one which gives you a value of t as 5 years, the other one which gives you a value of t as 7 years. So clearly both are possible, right? And so, either Dhanplan has an interest greater than Sanchay or the other way around. Since both outcomes are possible, mark option A. Okay, coming to the last question number 5 from the set. You need to disregard the calculations from the previous set before you do this, which is kind of unique. So make note of that. We're told that time invested in Sanchay is 2 years, which means time invested in Dhanplan will be one less than it, 1 year. We are also given that the rate, of Sanchay, we know that it's double of 4%, right? It's 8%, right? So assume n% to be the rate for Dhanplan. And you already know the principles, right? So if the ratio of simple interest in scheme 4 is 2 times the simple interest in scheme 5, simply put PRT by 100, right? And then solve this for n. Very simple solution. You get the value of n as 5%, right? So straight up, statement 2 is correct, right? Rate of interest is indeed 5% for Dhanplan. But the first statement asks you for the total amount earned, right? Which means principal of 50,000, right? Plus how much interest, right? Now, simple interest is P into R into how many years? Well, 2 years upon 100, right? So that indeed becomes 8,000 rupees, right? And you already have that here actually, 8,000, right? So if the interest is 8,000 and you invested 50,000, shouldn't you get 58,000 back? Right? So that does seem like the most likely, that the correct answer. So statement 1 is actually not correct. So since only statement 2 is correct, should mark option C here. All right, which brings us to the last set, the one based on the digits and the arithmetic calculations. I think if you've read the problem and the questions, you'll know the thing is to first solve, for all the variables and determine, which of these values can I be sure of, right? And how to attempt this. Well, you pick constraints that are easy to work with. So for example, the first constraint I'll pick here is equation number 2. We're given d plus e plus f is 7, right? And if you think about it, there's only one possibility. 1 plus 2 plus 4, right? The total becomes 7. But since you don't know which of these is which, variable, you simply assume that D, E, and F belong to the set 1, 2, and 4. Okay, they're distinct numbers that belong to this set. Okay, next condition I'll take is equation number 6, which says C times F minus I. Obviously, I chose this because we can try and evaluate which values of F are possible, which ones are not. So think about if F was 1, then you'd say the difference between C and I is 29, which is not possible. You can't subtract 2 digits and get a 2-digit number. So, and not just 1, I can't be even equal to 2, right? So F, cannot be equal to 1 or 2, which immediately says that F must be 4. Yeah, and if F is 4, then correspondingly D and E should be taking the remaining 2 values, 1 or 2, right? So I can plug that value in my table, right? Next condition, and also since F is 4, you're basically saying 4 times C minus I is equal to 29. So immediately you know that 4 times an integer C should exceed 29, right? And so it cannot be 7 or less than it. It has to be more than 7, which means it has to be 8 or 9. All right. Next equation I'll consider one that contains C again is equation number 1, right? A into B minus C is 22, right? What we know is that C cannot be 8 or 9 here, right? Why do I say that? Well, think about plugging the value of C as 8 or as 9. If C is, actually, it can be only 8 or 9 here, right? So we simply plug that value, those values here. If C were equal to 8, then A into B minus 8 equal to 22, which means A into B would have been 22 plus 8, 30, or 22 plus 9, 31, right? So the product of 2 digits A and B comes out to be either 30 or 31, right? Now, easy to rule out 31, right? So there are no 2-digit numbers, 2 single-digit numbers whose product can be a prime number, right? So A into B cannot be 31, which means C cannot be 9 either, right? Which means C must be 8. And when C is 8, A into B is 30, which means A and B can only take values which are 5 and 6. I don't know which is which, but those are the constraints, right? And since we know the value of C, I'm going to plug that in my table. All right. Moving on. Next equation I will consider is equation number 4, right? This one says A into D plus G is 17, right? We've already sort of narrowed down some values for A and some values for D, right? We know that A can only be 5 or 6 and D can only be 1 or 2, right? So since you have the product A into D over here, let's calculate what happens, right? Now imagine if D were 1 and A were 5, then 1 into 5 plus something should become 17. But then that means that what you add must be 12, but G can't be a 2-digit number, right? Similarly, if I put 1 and 6, I'll get 6 plus 11 is 17. And again, G cannot be 11, right? So what that tells me is that D cannot be 1, right? And so which means D must be 2. And if D is 2, then correspondingly, E must be equal to 1. Because remember, D, E, and F were respectively belonging to the values 1, 2, 4. Since F is already 4 and D is now becoming 2, E must be equal to 1, right? So you have those values D, E, and F. And once you have those values, you can also again plug those values here. A into D plus G, right? So from here, I can solve it a little later though, right? So first, let's look at equation number 5, right? So what you know in this equation now is that, well, E is 1. You also, if E is 1, then B plus H will become 16 minus 115, right? But remember now, since C is equal to 8 or 9, in fact, C is 8, right? We already know C is equal to 8, right? 15 as a total can either come with 7 plus 8 or with 9 plus 6, right? But since C is already 8, this combination cannot happen. It will be this combination, right? 9 plus 6, which basically is a conveniences you a lot, right? So you know that B plus H is 15, but we also know that A and B can only be either 5 or 6, right? So since B plus H needs to be 15, it means B must be 6 and H must be 9 and A then must be 5, right? So I have A, B and H. I can plug those values in the table and consider one more equation, right? Let's consider, in fact, A into D plus G, right? Now we've solved it. We know the value of A. We know A is 5 and we know D is 2, right? So 5 into 2, 10. What should be added to 10 in order to make 17? Well, you should add 7, right? So the value of G must be equal to 7 units. And finally, if you consider, and after plugging that value in the table, if you consider the equation number is 3, right? G plus H plus I is 19. We already know the value of G and H, right? We know G is 7 and H is 9, right? And so if you plug those values, you'll get the value of I as 3, right? So successfully completed my table, right? And once you've completed the table, answering the specific questions is very easy. What is the value of C into C? That's 8 into 8, 64, plus I into I, 9 into 9, 3 into 3, 9, divided by C square, and that's 64, minus I square, that's minus 9, right? So what is the answer, right? 64 plus 9 is 73, and 64 minus 9 is 55. And so it's a value which is greater than 1. It's not less than 1. It's not equal to 1. It can be determined, right? So correct answer, option A. What about the next one? What is the value of H, right? We already know that the value of H is 9, right? So correct answer, option C. Question number 3. What is the value of D cube minus E cube, right? So D cube is 8 and E cube is 1. So 8 minus 1 divided by 8. Sorry, that's not 8. 2 square, that's 4. Plus D into E, that's 2 into 1, 2. Plus E square, which is 1, right? So what you're getting is 7 divided by 7, which is indeed equal to 1. So the correct answer here is option C. Fourth problem, find the value of B plus G, right? We know B is 6, G is 7. So 6 plus 7 is 13 into B square, that's 36, minus BG, that's 6 into 7, 42, plus G square, plus 7 square, 49. This, and then the third bracket, which is C into A plus C plus E. C into A is 40 plus E is 1. 40 plus 1 is 41 minus C into C is 8. 8 into 3A square, right? So 3 times 25 is 75, right? So this is what you get, right? So you calculate, is this greater than 1, less than 1? Let's check it out, right? 42 minus 49 will be 7, right? So this becomes 36 plus 7, 43. So 13 into 43 plus 39 minus 8 5s are 40, 8 7s are 52, 60 minus 600. So 13 3s are 39, 13 goes are 52 plus 3, 55 plus 39 minus 600. So clearly you're getting a value which is less than 1. The last question, find h square plus a square. H square is 81 plus a square is 25 plus c square, that's 64, plus 2 into HA, that's 9 5s are 45, plus AC, that's 5 8s are 40, plus CH, that's well, that's 8 into 9, that's 72. What is this total? Well, uh, on adding, you get 170 plus 2 times. This is 40, 85, 157. Right? So that's 170 plus 314. That means that's 484. Right? And that's option A from the given choices.